Good morning and welcome to today's lesson on linear equations and the types of linear equations that we're going to be working with. Now, in our last lesson we did a lot of vocabulary. We had to define what is a linear equation. Well, linear equation, as we recall, linear has the word line right in it, so it has to do with the equation of a line. Okay, it's a definition, it's a description of all of the points on a line. So if we draw a line, the equation of that line describes all the points. By the end of all of this, we're going to be able to write our own equations for lines based on the actual graphs. We're going to make our own graphs based on the equations. We're going to be able to go back and forth. We're going to write different formats. We're going to do a lot of things with linear equations. Okay, so let's just start at the beginning. Okay, obviously we're talking about a line, but there are different types. Okay, so let's talk about the different types of linear equations. Okay, we're always going to be on a graph like this. Okay, this is called the Cartesian coordinate plane. Some people like to call it a T-graph. Okay, it's just a graph. Okay, we're never cutting it off. We're not looking at parts of it. You could. Sometimes there are situations where you're only interested in things that happen that are positive because negative numbers don't happen because maybe we're talking about population growth or something like that. So the first equation we're going to look at, I think I'll switch colors here, look like this. That might be a little hard to see, that particular green. Make it a little darker, a little more thicker. Won't use that green so much anymore. I think we'll switch over to the red. What kind of slope is that? That's how we quantify. That is one of the ways we describe an equation, a linear graph. And that is something that we can use, that we can tell, we can walk right up and go, I know what kind of slope that is. This has a positive slope. It is going, as my eyes go from left to right, because when we read English, Spanish, French, German, Italian, Portuguese, most languages, not all of them, but most languages, we read from left to right. Well, English is the one we're using in this country, so let's just stick with that. We read from left to right. So as my eyes are going from left to right, this is clearly going up. Now the arrow says it's going in both directions, but my eye tracks from left to right, and that is why we call it a positive slope. We'll abbreviate that with POS, positive. Okay? Next up, I think it's pretty clear what's going to come next. Oh, now let me give you an equation here. So I'm going to come back to that one. Y equals 3x minus 4. And it's a positive slope because this number right here is positive. It is not just a name. It actually has something to do with the number that generates it. And the number that generates it is right here. This is the slope. And we will talk more about this when we talk about the different forms of a linear equation. We're not quite there yet. That'll be something we deal with soon, but not quite yet. Obviously, this one, same situation. My eye is tracking down as I look from left to right. So this would be a negative slope. The equation here would look like this. Y equals negative 2x plus 1. Because this number is a negative number, this is a negative slope. So it is a description not only of the number that made it, but of how it looks visually. And that's really useful because that means anybody can walk up and see, hey, this is negative. Okay, and this is stuff that you might use if you were a stockbroker and you were trying to decide if this trend was going up or down. Right? You would look at it from left to right, what's happening from day to day. You might use this as a biologist, as a population description. Maybe this is the population going up because more and more of them are out there. This happens when you take away the predator, suddenly there's bunnies everywhere. Or maybe this is going down because their habitat is being erased and you're losing animals and therefore their population is going down. So these are the kinds of things that, so this is a positive trend, this would be a negative trend. These are the kinds of things we use actually in a lot of different areas. Okay, it's not just a, hey, look, I'm making you learn this in math and you don't use it anywhere else. Those were some simple off the top of my head ideas. Population growth and stock market trends. Okay, and I'm sure people are always interested in stock market trends because it could mean the difference between making money and not. Could be a sporting trend, I don't know, all kinds of things. Now, the other two types of slopes are a little weird, okay? And they're very uncommon, okay? We will only see them maybe 5% of the time for the other two types, okay? Positive and negative is almost every, like I said, 95% of the time, okay? So if you didn't understand the other two types that I'm about to show you, you could still get an A because you could understand the other 95%, okay? But let's look at the other two types, and boy, didn't like that green. It's basically flat. This is a zero slope. Okay? Don't say it doesn't have a slope. The slope is zero. Remember how we talked about, it's not that we skip things, we don't say it doesn't exist, we just acknowledge that the slope is zero. If I were to write that equation, that zero would be there, but we would never write 0x. We just wouldn't. Like, why would we go around acknowledging that there's all these extra zeros that are just not being used? Hey, how much does he give you? He gave me $22 plus $0. Why did you bother with the plus 0? He, just give me the number. So we would just write it like that. One variable, y. And that's a little tricky, okay? Because you kind of know it. This is one of those times we're going to show you. I'm going to show you how to make a graph, how to take an equation, turn it into a table, and turn that into a graph. This one, you kind of just have to know it, or you're just not going to get it. You either know that y equals 3 is a horizontal line with a zero slope, or you don't. Okay, because there's not much for you to, you can't make a table, you can't really calculate anything, you either kind of just know or you don't know. Okay? The other one is even weirder. If you remember back to the last lesson, we talked about this. This is a vertical, this is, by the way, a horizontal, I said the word and now I want to write it, horizontal line. This is a vertical line. Now, if you remember from the last lesson, in a vertical line, it fails to be it's not a function. It fails the function test. It's the definition of failing the function test. It fails the vertical line test. So what kind of slope is it? This is where it gets weird. Undefined. That is the type of slope it is. Because what we're really doing here, and when we see the slope function, when we learn how to calculate our own slopes, what we're actually doing here is dividing by 0. And when you divide by 0 in math, things explode. And instead of just saying, well, things explode, we just said, well, there is no way to define this. It is an undefined quantity. The slope is undefined. And this is, x is the only number we have. We don't even have a y value. Here we didn't have an x value, here we didn't have a y value. This one's a little easier to understand because the reason we don't have an x value is that the slope was 0. This is undefined, it's even less, it's very confusing sometimes. Fortunately for us and you're only going to encounter this, I'll be honest, maybe 1.5% of the time, if even that much. Okay, maybe just 1% of the time you're going to encounter an undefined slope where you only have an x value and no y value. So I wouldn't get too upset about this. Just have that moment in your brain where you go, oh, this is weird. This is that weird time, and I would, it's like, that's a 0 and that's an undefined, whatever. I'll figure this out when it comes up. I'll suddenly remember, hey, something's weird. Oh yeah, it's one of those weird ones. And then hopefully you can figure out which slope is which. Because honestly, Together, they're 5% of the time. And this one's probably 3, and that one's probably 2, maybe even 3.5 and 1.5. So if you know the zero slopes are much more useful and come up more often and maybe are actually something you might see. Vertical lines and undefined slopes, because you can't do any math with them. It's like, hey, it's an undefined slope. Thanks for noticing. And you just move on to the next one. That's really all that happens. Okay, so don't let this bother you too much. Positive and negative, much more important. Okay, what kind of slopes those are and how that relates to the number that's in the spot that is, we're going to actually define as the spot named slope in a bunch of different formats. But again, we'll do that in the next lesson, not this one. Okay? All right. So, let us take, okay, let's go ahead and, graph a linear equation. Okay, we got ourselves a linear equation here. Got an x, got a y, it's probably linear. If it has an exponent, it's something else, and we're not going to do anything with that in this class. That's for next year, that's for high school, that's for later. We're only going to focus on linear, and that is only going to have no exponents. Now, I just said graph. I'm not sure I gave you enough directions, so let's take it back up a step. So what I want us to do is make a table. This is my big suggestion. Okay, you're going to find that after you've gotten good at making a table, the better you get at it, the less you'll need to do it. And eventually you'll be able to do a graph without the need to make a table at all. In fact, you'll be able to graph a linear equation without a table in, like, I'm not exaggerating here, like 10 seconds. Let's make it a little longer, 15 seconds. Okay? But for right now, we're gonna do it the long way. Okay? And again, I always feel like you can't appreciate a shortcut until you've done the long way. So what do I mean by make a table? Well, in the homework, they're gonna say, hey, by the way, graph this when your domain, they're gonna give you your domain. They're gonna say, hey, how about a domain of, let's go -2, 0, and 3. Let's be weird. Okay? They could give you any numbers they wanted. It doesn't matter. It's always good to have numbers that are small, close to what we call the origin. That's the middle of a graph. And it's always good to have a 0, and it's always good to have a negative, because negatives act differently when you start getting into graphing that isn't linear. So again, this is me thinking ahead for you. So what do? We make a table. Now they make them horizontally. I like to make them vertically, and it doesn't make any difference to me. But I'll show you, I'm going to show you vertically first because I like it, and I'll show you why I like it. So domain, we know domain is x. So they're saying -2, they're saying a 0, and they're saying a 3. What they're asking you to do is to put this -2 where the x is and solve it for the y value. So they're saying, okay, well, y equals 2 times -2 minus 1. Well, 2 times -2 is -4. -4 minus 1 is -5, and that is that's my y value. Now they're asking me to do it again with the 0. So y equals 2 times 0 minus 1. Well, 2 times 0 is 0, minus 1 is -1. And now they're asking me to do it a third time. Y equals 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. Now, why do I like to write it this way? Because what I've now created is an x and a y. That is an ordered pair. That is a point on a graph. So this is the point -2, -5. This is the point 0, -1. And this is the point 3, 5. Okay, that is what I have just done, is created ordered pairs. Points that I can now place on a graph. So let me give myself some room to make a graph. So there's my x, there's my y. Okay? Doesn't have to be perfect. A lot of them, they're going to provide you with some space to graph on, but if you have to draw your own, it doesn't have to be perfect. But I start with the point -2, -5. So -2 on the x, and -5, 2, 3, 4, on the y. There's my first point. 0 on the x, so I don't move. -1 on the y. Go back. The last one is 3. 1, 2, 3, comma 5. 1, 2, 3, 4, 5. Now, if I've done this correctly, these 3 points are going to line up. Okay, I told you it wasn't perfect, but that's pretty darn close for what we call freehanding. Plus, it's also I'm writing that way instead of, I'm not turning my back on you guys, so I'm writing this way. It is a linear equation. That is a line. That is the equation of a line. That is the points that are generated when I make a table, and that's the graph when I put them on a graph together. Okay, so they're gonna ask you to graph linear equations. Sometimes they'll say make a table and graph. Sometimes they'll say here's your domain. They might just say what's the range. That's one of the questions that sometimes comes up. So again, if I knew the domain is that, I could say, well, what's the range? Well, the ranges were -5, -1, and 5. That was the range. Okay, what were the output values? What came out after I put in the numbers that they asked me to put in? Okay, and how does it look when I graph it? Okay, so they may ask you to graph, they may ask you to make a table and graph, they might ask you to just tell me the range, which just means put the x's in and see what comes out. Okay, they might ask you to then acknowledge that they're ordered pairs. Again, lots of different ways to use this information. Okay, but for us, this is how we're going to do it. Now, at some point, all it's going to say is graph y equals 2x minus 1, and it's going to be all on you. What numbers do you put in for the domain? It's all up to you. Okay. Again, I suggest small numbers because they're near the middle, and I always choose a negative number because they act differently when you get into exponent stuff later on. Okay, but I promise you, there will come a time when you'll be able to graph this without the need to make a table at all. In fact, you'll be able to do it in like I said, 15 seconds. It'd be super quick. Okay? One more task. And we're gonna put it all together. We're gonna kind of do one big uber problem here. Okay? And we're gonna say solve for y, then make a table and graph. Okay, that's a lot. So it's asking us to do it all. Okay, and we haven't talked about solving for y yet. It's a little weird. Okay, that's what I want to talk about next. Okay. What do I mean? No, we'll make it hard. Yeah, I'm going to make it hard myself. Solving for y. What do I mean when I say solve for y? We used to say solve for y in terms of x. It's kind of like saying, I want you to describe my weight as a function of your weight. I don't want mine in pounds. I want me as like, how many of you am I? And maybe you have to add a pound because I'm like 1.5 of you and 2 more pounds, or 2 pounds less than that. I don't know. What I'm saying is I want it to look like this, and we're going to talk about this form in our next lesson. It's a really important form. Okay, it's called slope-intercept form. Some of you may have heard of it, may remember it, might have gone, oh yeah. We'll talk more about that in the next lesson, okay? As it is, I want it to be in that form. That means I want the y on the left-hand side. Well, you know what? I remember from a previous lesson that says I can just pick this up and put it over here. And then I got to put this on the other side. And I'm pretty close to having it the way I want it to be. I want the y by itself, so this needs to go. There's nothing to, so 0 minus 1 is just minus 1, negative 1. And now I have rewritten the equation. I have solved for y in terms of x, because y now is 3x minus 1. I have now created, I have a linear equation in a particular format. This one actually has no name. It's a linear equation, don't get me wrong. It just doesn't have a name. It doesn't have a, it's just a linear equation. This is a linear equation in a very specifically named form called slope-intercept. We'll talk more about that in the next lesson. All I want to do with it now is I want to make my table. Now, it didn't give me a domain. No one gave me a domain. So what do I pick for domain? Whatever you want. Pick easy numbers. Okay? A lot of people like to just go 1, 2, 3. Like, no. Always recommend picking 0. And I even like to pick a negative numbers, but I'm not even gonna pick a negative. I'm just gonna be easy on myself. But I am gonna pick 0. I always want to pick 0 because it doesn't get much easier than 0. Because y equals 3 times 0. 3 times 0 is 0. Minus 1 is negative 1. 3 times 1 is 3. 3 minus 1 is 2. 3 times 2 is 6. Minus 1 is 5. I have now created 1, 2, 3 ordered pairs. And now, the last thing it asked me to do is to graph it. This is a very complete problem. This is one of the things I like about it. It asked us to do a lot of different things. Really, what it might have just said at the beginning is graph. It could even have just said, the very beginning of this equation, solve. Could have just said graph. In that format, it's kind of tricky. Getting into this format is important. And we're going to be doing a lot of moving equations around and flipping things and making them look different. We're going to see there's 3 different formats for a linear equation that we actually care about, kind of almost a 4th one if you count function form. And we're going to want to move back and forth between those forms. So the last thing I'm going to do here is I'm going to go graph it. So 0, negative 1. So let's just throw down some points, some little marks here. So 0, negative 1 is right here. 1, 2 is right here. And 2, 5 is right here. And look at that, nice straight line. Tells me it's all done right and I'm happy about how it looks. Okay? That's what we want. When all is said and done, the ability to make a graph. The ability to change an equation to look different, the ability to make a table to generate ordered pairs, the ability to plot those points onto a graph, and the ability to connect all the dots to create the actual graph of a line. Okay? So, hope that helps, and I will see you in class or in office hours.